There's a lock icon in your address bar, and almost everyone reads it as, "This is encrypted." That's not what it means. The lock means your browser proved who it's talking to, that the server on the other end really is the site you typed. Encryption is the easy half. This is the story of the hard half, identity. Here's the shape of it. Before your browser sends a single byte of your request, it runs a handshake. The server proves its identity with a certificate. A chain of authorities vouches for that certificate up to a root your device already trusts. And only then do the two sides agree on a key and start talking. Prove, agree, then talk. Understand that order, and the lock, and every certificate error you've ever clicked past finally makes sense. Start with what the lock is not. Encryption, scrambling the bytes so nobody between you can read them, is the easy part. Two machines do it in milliseconds. The hard part is identity. You've opened a private channel, but private with whom? Someone sitting in the middle can encrypt just as well as the real server. So the real question TLS answers isn't, is this secret? It's, is this really them? So before any data moves, there's a handshake. Your browser says hello and lists the ciphers it speaks. The server says hello back and presents its certificate. Think of the certificate as an ID card, a signed document that says, "I am stewmore-dev, here's my public key." Nothing secret has been sent yet. This is the introduction, a claim of identity your browser now has to check. Open that certificate up. Inside, the domain name it's for, the server's public key, who issued it, and the dates it's valid between, all sealed with a digital signature from the issuer. That signature is the magic. Change a single byte of the certificate and it no longer matches, so nobody can forge or tamper with one. But notice what it proves, that whoever holds this controls that name. Not that the name behind it is trustworthy, just that it is who it says. But your browser has never heard of stewmore.dev, so why believe its certificate at all? Because someone it does trust vouched for it. The site's certificate was signed by an intermediate authority. That intermediate was signed by a root authority. Each link vouches for the one below it, a chain of signatures reaching up to a root your device already trusts. Follow the chain to a name you trust, and the leaf is trusted too. And where does that trust actually start? Your device ships with a list, the trust store, of a few hundred root authorities it's decided to believe, baked into the operating system and the browser. A certificate chain is only accepted if it ends at one of those roots. Anyone can generate a certificate for any name. What they can't do is get it chained to a trusted root without proving they control the domain. That's the whole game. And it's why a valid lock proves the name is genuine, not that the people behind the name are. Now that identity's settled, both sides need a secret to actually encrypt with, so they run a key exchange. Each contributes a piece, mixed together into one shared key. And the beautiful part is an eavesdropper can watch every message go by and still can't reconstruct it. Modern TLS makes that key ephemeral, thrown away after the session. So even if the server's private key leaks next year, today's conversation stays sealed. That's forward secrecy. All that proving sounds slow, a round trip or two before your request even starts. So TLS does it once. After the first handshake, the server hands your browser a ticket, proof you've already been vetted. Next time you connect, you present the ticket and skip the whole ceremony, straight to encrypted, sometimes with your request riding along in the very first packet. The first visit does the work. Every visit after is nearly instant. So where does it break? You've proven identity, agreed a key, sealed the channel, and then the page loads one script over plain HTTP. That single asset is unprotected. Anyone in the middle can swap it. And a chain of trust is only as strong as its weakest link, so the browser voids the whole thing. The lock turns into a warning. That's mixed content. Serve everything over HTTPS, or you've bolted the front door and left a window wide open. So here's the whole model in one breath. The lock isn't encrypted, it's a proof. A handshake presents a certificate. A chain of authorities vouches for it, up to a root your device already trusts. Both sides agree a key only they hold. And from there, everything's sealed. Prove identity, agree a key, then talk. That's what your browser checks in the quarter second before a secure page ever loads. The request is finally trusted and encrypted, a private line to a server your browser is sure of. But it still hasn't done a thing. Now the packets actually arrive at that machine, and something has to wake up and handle them, the server and the framework running on it. That's where we go next.